The solitary teenager hacking in a basement is dead. Today, the gaming industry is fighting a $300 million black market run by highly structured cybercrime syndicates. During the golden era of online shooters, roughly 2015 to 2021, cheating was a straightforward process. Hackers used executable programs to inject malicious code directly into a computer's RAM, skimming the exact X, Y, and Z coordinates of enemy players. Game studios struck back with massive force. They deployed systems like Riot Vanguard and Ricochet, kernel-level drivers that operate at the deepest, most privileged layer of the Windows operating system. Operating at this depth granted the anti-cheat software total supremacy over the PC. They could instantly spot and terminate any unauthorized process attempting to peek into the game's allocated memory. This chart shows recent enforcement trends against AI-based systems, and you can see a massive divergence. Automated bans have plunged 85%, while player reports of cheating are climbing to all-time highs. The security software didn't break. The syndicates simply stopped touching the game code entirely. They realized that if you don't read the memory, there is no digital footprint for the kernel to detect. The new standard relies on computer vision, the exact same object recognition technology that self-driving cars use to identify pedestrians. This diagram illustrates the data flow of a modern visual exploit. The raw video output from the primary gaming graphics card is routed through a capture card to a completely separate secondary machine. On that second device, a hyper-optimized neural network processes the incoming frames, identifying enemy models in under 10 milliseconds. Once identified, the AI calculates the optimal trajectory and fires a hardware signal back to the primary PC to execute the physical movement. That signal is fed through a spoofed USB controller like this Arduino board. To the Windows operating system, this external device authenticates as a legitimate human interface device. It just looks like a standard legal mouse. Because the neural network lives entirely on a second machine and sends inputs through a physical cable, the primary gaming rig remains completely uncompromised. Not a single byte of memory is read illegally. The kernel anti-cheat is completely blind. Beyond computer vision, syndicates are deploying an even more aggressive physical exploit known as direct memory access, or DMA hardware. These are physical boards inserted straight into the internal PCIe slots of a gaming rig. This architecture grants the card raw read and write speeds directly to the system's volatile memory. This setup completely bypasses the central processing unit and the Windows OS. The extracted location data is beamed instantly outward to an external tablet or laptop, rendering a perfect real-time radar of every player on the server. Game developers have started deeply scanning the hardware bus to identify these unauthorized cards. In retaliation, cheat vendors sell firmware updates that dynamically alter the hardware's ID, disguising the illegal board as a harmless Wi-Fi adapter or audio card. When exploit hardware can mimic a Wi-Fi card at the silicon level, local security software loses its most basic advantage, the ability to trust the hardware it's running on. To catch these players, developers are being forced to stop looking at the machine and start looking at the movements. To counter these undetectable client-side exploits, game studios are moving the front line. They are abandoning the player's hard drive and shifting defensive operations into massive cloud-based server networks. This is server-side AI. Instead of scanning a local computer for malicious files, cloud supercomputers are now running deep behavioral analysis across millions of data points simultaneously to profile a player's physical movements. If we look at aiming patterns, the contrast is obvious. Human biology is limited by reaction time and natural wrist jitter, resulting in an erratic scatterplot. A cheating algorithm creates a perfectly straight mathematical vector, snapping to a target with zero deviation. The server-side model ignores the local hardware entirely. It simply calculates that the physical mechanics of a human wrist cannot reproduce those movements, and issues a ban purely for inhuman behavior. But the syndicates have already countered. Black market AI aimbots are now equipped with humanization protocols. They actively inject randomized errors, simulate organic wrist jitter, and delay their target locks to deliberately bypass the server's scrutiny. Because remote online environments are now inherently compromised by undetectable tech, major esports tournaments with vast prize pools are being restricted strictly to physical LAN stages where organizers can manually control the hardware. We are watching bots learn to fake human mistakes to defeat other bots designed to catch them. As long as cheating generates hundreds of millions of dollars, we will be stuck in an algorithmic Cold War. playing in a reality where you can never truly be certain if your opponent is a person or a neural network.